Let's get started with the topic straight line. And previously we have discussed PYQs related to direction ratios, direction cosines and planes. So if you want to see those videos, you can just go to Analytical Geometry playlist on the channel and just see them. So let's get started with the straight line questions. So the question number 1, which is asked in the recent paper, is we are supposed to find the image of this line in the plane this. So first let us just see graphically what we are supposed to find and then we'll move ahead. So if this is my given plane and this is my given line, so I am supposed to find image of this line with respect to this plane. So if I assume this to be my mirror, then this will be my image of the line. This will be image of the given line. Here this point is, let's say P. This is the intersection point of given line with the plane. And if this point is Q, then let's say this point is Q dash. So the image of point Q in the plane is Q dash. So using the foot of perpendicular from point Q to the plane, I can get this point, let's say it is R. So we know that image of with respect to any plane, projection with respect of any point with respect to the given plane will be equidistant to the image as well. That is, if this distance is, let's say, small m from Q to R, then distance from R to Q dash is also small m. So we can easily find out value of P and value of R. And then using midpoint formula, I can calculate the coordinates of Q dash, and using that I can find the line PQ dash, which is basically the image of line PQ. So let's just solve this equation. So the given line is x equals to 3 minus 60, y equals to 2t, z equals to 3 plus 2t. So if you see that this is any arbitrary point on the given line. So if this line intersects plane P, then these values of x, y, z must satisfy the equation of plane. So from here I got 3 times 3 minus 60 plus 4 times 2t minus 5 times 3 plus 2t plus 26 equals to 0. So if I simplify this, I'll get 9 minus 18t plus 8t minus 15 minus 10t plus 26 equals to 0. So if I simplify this, minus 18t plus 8 minus 10t and this one minus 10t. So I'll get minus 20t plus 9 minus 15 plus 26. 9 plus 26, 35, and 35 minus 15 is 20, which is equals to 0. So from here I got value of t as 1. So if I just substitute this value of t in the given line, which is in parametric form, then I'll get value of coordinates of P. So my point P is minus 3, 2, 5. Now let us just find the foot of perpendicular of any line from point passing from point Q. So if I write my given line PQ in a symmetric form, so I'll get PQ line in symmetric form. So I'll get x minus 3 upon minus 6 equals to y minus 0 upon 2 equals to z minus 3 upon 2 equals to t. So this is my PQ line in symmetric form. So if we observe that PQ line is passing via point 3, 0, 3. And I know that if any equation passing via point 3, 0, 3, which is perpendicular to the given plane, then the direction cosines of that line must be parallel to normal of the plane. So using that, I can find any equation of any line passing via this point, which is perpendicular to the given plane. So equation of line via, let me name this point as Q, via Q and perpendicular to given plane will be of form x minus 3 upon 3 equals to y minus 0 upon 4 equals to z minus 3 upon minus 5. So from here I can calculate any arbitrary point on this perpendicular line of the plane. So let me equate it with r. So any arbitrary point on this line will be 3r plus 3, 4r minus 5r plus 3. So if this perpendicular line is passing through any point, passing through the plane, then it must intersect the equation of plane. So just substituting this value in the equation of plane, I'll get 3 into 3r plus 3 plus 4 into 4r minus 5 into minus 5r plus 3 plus 26 equals to 0. So if I simplify it, I'll get 9 plus 16 plus 25r plus 9 minus 5 3 is 15 plus 26 equals to 0. So if I further simplify it, I'll get 16 plus 9 25 and 25 plus 25 50r plus 26 plus 9 35 minus 15 20 equals to 0. So from here I got my r as minus 2 by 5. So if I substitute value of r in this point, so I'll get my r coordinate. So r point is 3 minus 3 into 2 by 5 comma 4 into minus 2 by 5 comma 3 minus 5, this will be plus 2 by 5. This is equals to 5 3 is 15 minus 6, 9 by 5, and it is minus 8 by 5 comma 5 3 is 15, sorry this 5 balances out this one, so it is 3 plus 2 which is 5. So this is our r point, which is basically foot of perpendicular from of a line which is passing through Q. So but we in question they have asked us to find the image of line, not the projection. So we know that r will be midpoint of image of point Q with respect to this plane. So using midpoint formula we'll get, using midpoint formula r must be equals to q plus q dash plus by 2, and this we'll do coordinate wise. So 9 by 5 equals to let q dash be alpha beta gamma be my q dash. So and q is my point, q is 303. So 3 plus alpha by 2, likewise minus 8 by 5 equals to 0 plus beta by 2, and my 5 equals to gamma plus 3 by 2. So from here I can calculate value of alpha beta gamma. So if I simplify it, I'll get alpha as 9 to the 18 by 5 minus 3, beta as minus 16 by 5, and gamma as 5 to the 10 minus 3 which is 7. So my q dash point is 18 minus 15 which is 3 by 5 comma minus 16 by 5 comma 7. This is my q dash point, and we have already calculated point P. So point P is this one, minus 3 comma 2 comma 5, minus 3 comma 2 comma 5. So line PQ dash is basically image of PQ with respect to plane, and given plane is 3x plus 4y minus 5z plus 26 equals to 0. So we have 2 points and we can easily calculate equation of line using these 2 points. So equation of line PQ will be, PQ dash is x plus 3 upon 3 by 5 plus 3 equals to y minus 2 upon minus 16 by 5 minus 2 is equals to z minus 5. Z minus 5 upon 7 minus 5. On simplifying it, I will get x plus 3 upon 5 3 is 15 plus 3, 18 by 5 equals to y minus 2 upon minus 26 by 5 equals to z minus 5 by 2. Yeah, I can just multiply by 5 by 2. So if I just multiply by 5 by 2, I'll get x plus 3 by 9 equals to y minus 2 by minus 13 equals to z minus 5 by 5. So this is the required image of the given line with respect to the plane. So now let us move on to next question. So the next question is, they have given us two straight lines, this and this, and they have asked us to prove that these straight lines intersect, and further they have asked to find the equation of plane containing them. Also find their point of intersection. So if you take hint from the question itself, they have asked us to find the point of intersection. So if we just assume that these two lines intersect and find a point where these two lines meet each other, then that will also prove that these lines intersect, because we'll get a common point which is same, where these two lines intersect. So let us do that. So my equation 1 is, let me name it as n1, x minus 1 by 2 equals to y plus 1 by minus 3 equals to z plus 10 by 8. Let me equate it with r1. And my equation line L2 is x minus 4 by 1 equals to y plus 3 by minus 4 equals to z plus 1 by 7 is equals to r2c. So I can calculate any arbitrary point on line L1 and L2. So any arbitrary point on L1 be, let's say, A. So my coordinates of A will be 2r1 plus 1 minus 3r1 minus 1, 8r1 minus 10. And on L2 B, let's say, so my coordinates of point B will be r2 plus 4 minus 4r2 minus 3, 7r2 minus 1. So if my line L1 and L2 intersect, then L1 and L2 intersect, then there must be a common point. So if there is a common point in line L1 and L2, so there must exist a value of R1 and R2 where the value of coordinate A and coordinate B are same. So using that logic, let us equate point A and B. So on equating A and B, I will get 2r1 plus 1 equals to r2 plus 4 minus 3r1 minus 1 equals to minus 4r2 minus 3, and 8r1 minus 10 equals to 7r2 minus 1. So if I just simplify these, I'll get 2r1 minus r2 equals to 3 and minus 3r1 plus 4r2 equals to minus 2 and 8r1 minus 7r2 equals to 9. So let us just solve these two equations and see what we get. So I can just multiply equation 1 by 4. So I'll get 8r1 minus 4r2 equals to 12 and minus 3r1 plus 4r2 equals to minus 2. So if I just add these two equations, I'll get 5r1 equals to 10. So from here I got r1 as 2, and if I just substitute value of r1 in the first equation, which is this one, I got my r2 as 2 into 2 minus 3, which is R2 as 1. Let us just substitute these values of R1 and R2 in this equation to see if they satisfy this as well. So 8 into 2 minus 7 into 1, which is equals to 16 minus 7, which is equals to 9, which is our left hand side. So these values of R1 and R2 satisfy this equation of R1 and R2 as well. So we got a common point where L1 line and L2 line intersect. So intersecting point of line L1 and L2 is either substitute value of R2 in B or R1 in A, both will give the same value. So the intersecting point is 5, minus 7, 6. So this is our intersecting point. Further, they have asked us to find the equation of plane containing them. So we have a direct formula for this. So equation of plane containing two lines x minus x1 by L1 equals to y minus y1 by m1 equals to z minus z1 by n1, and x minus x2 by L2 equals to y minus y2 by m2 equals to z minus z2 by n2 is x minus x1, y minus y1, z minus z1, L1 m1 n1, L2 m2 n2 equals to 0. So I can just substitute values of these from the given equation, then I'll get equation of required plane. So it is equals to x minus 1 y plus 1 z plus 10, x minus 1 y plus 1 z plus 10, and value of direction cosines are 2 minus 3 8, 2 minus 3 8, 1 minus 4 7. Let's just double check it once. 1 minus 4 7, yeah, that's correct. So now we just need to simplify it to get the equation of required plane, which is x minus 1 minus 7 3 is 21 plus 8 was 32 minus y plus 1 14 minus 8 plus z plus 10 into minus 8 plus 3 equals to 0. So if I just simplify it, I'll get 32 minus 21 11 minus y plus 1 14 minus 8 6 plus z plus 10 3 minus 8 minus 5 equals to 0. On further simplifying it, I'll get 11x minus 6y minus 5z minus 11 minus 6 minus 50 equals to 0, which is equals to 11x minus 6y minus 5z minus 61 minus 67 equals to 0. So this is my required equation of plane, which is containing both line L1 and L2. Now let us move on to question number 2. Next question, I guess this is question number 3. So the question says that show that the line this and this intersect, find the coordinates of point of intersection and the equation of plane containing them. So it is the exact same question, just the values are changed as we have done previously. So my equation L1 is x plus 1 by minus 3 equals to y minus 3 by 2 equals to z plus 2 by 1 equals to r1. So any arbitrary point on line L1, let it be A. So it will be minus 3 r1 minus 1, 2 r1 plus 3, r1 minus 2, and equation of line L2 is x by 1 equals to y minus 7 by minus 3 equals to z plus 7 by 2. Let us equate with r2. So any arbitrary point on line L2 will be, let us name it as B. So it will be r2 minus 3 r2 plus 7, 2 r2 minus 7. So if these two lines intersect, then there will be a common point in between these two lines. So to find out that common point, let us just equate coordinates of point A and point B. So on equating we'll get minus 3r1 minus 1 equals to r2, 2r1 plus 3 equals to minus 3r2 plus 7, and r1 minus 2 equals to 2r2 minus 7. So on simplifying these I'll get minus 3r1 minus r2 equals to 1, 2r1 plus 3r2 equals to 4, and r1 minus 2r2 equals to minus 5. So if I just multiply first relation between r1 r2 with 3, so I'll get minus 9r1 minus 3r2 equals to 3, and 2r1 plus 3r2 equals to 4. If I just add these two equations, I'll get minus 7r1 equals to 7. So from here I got my r1 as minus 1 and r2 as minus 3r1 minus 1, which is equals to 2. So my r2 is 2. So let us substitute these values of r1 and r2 in this relation to see if this satisfies. So my r1 is minus 1 minus 2 into 2, which is equals to minus 5. So this relation satisfies. So intersecting point of L1 and L2 is, it is 2, 7 minus 6, 1, and 4 minus 3 minus 3. So this is a common point. Further, they have asked us to find the equation of plane containing them. So using the formula which we discussed in previous question, so equation of plane containing line L1 and L2B will be x plus 1 y minus 3 z plus 2, and direction cosines are minus 3 2 1 minus 3 2 1 and 1 minus 3 2 equals to 0. So if we just simplify this, we'll get x plus 1 into 4 plus 3 minus y minus 3 into minus 6 minus 1 plus z plus 2 into 9 minus 2 7, which is equals to 0. So on further simplifying it, I'll get 7x plus 7y plus 7z plus 7 minus 7 3 is 21 plus 14 equals to 0, which is equivalent to x plus y plus z equals to 0. So this is the equation of plane which is passing through the given line L1 and L2. So now let us move on to another question. So the question says that find the projection of straight line on the plane. So here they have asked to find projection of the line, not the image. In the first question they have asked us to find image of the line. So if this is my plane P, and this is the given line Q, let me name it as P. So I am supposed to find this projection of line PQ on this plane. So the given line is L1 is x minus 1 by 2 equals to y minus 1 by 3 equals to z plus 1 by minus 1. So L1 is passing via point 1, 1, minus 1. So, and any arbitrary point on L1 will be of form, let us equate it with R1 BP, so it will be 2R1 plus 1, 3R1 plus 1 minus R1 minus 1. So if this line is intersecting this plane somewhere, So this point must satisfy the equation of plane. So we'll just substitute this value in the equation of plane. We'll get 2r1 plus 1 plus 3r1 plus 1 plus 2 minus r1 minus 1 equals to 6. So if we just simplify it, we'll get 3r1 plus 1 plus equals to 6. So from here I got my r1 as 2. So using this value of r1, we can just find the intersection point of line and the plane. So intersection point P will be 5, 7, minus 3. So this is my intersection point. So if you observe that if I get any other point of the projection line, I can easily find equation of the projection line. So we know that foot of perpendicular of any line passing via Q, we can easily calculate because we know point Q and equation of plane. So equation of normal to plane via point Q will be x minus 1 upon 1 equals to y minus 1 upon 1 equals to z plus 1 upon 2. Let us equate with R2. So we'll get any arbitrary point on line which is perpendicular to the given plane. So any arbitrary point here will be, let us name it as R. So it will be R2 plus 1 to R2 minus 1. So since foot of perpendicular of a line which is normal to the plane and passing via Q will intersect the equation of plane. So if we just substitute this value of R in given equation of plane, we'll get the intersection point. So we'll just do that. So if we just substitute this in equation of plane, we'll get R2 plus 1 plus R2 plus 1 plus 2R2 minus 1 into 2 is equals to 6. So if we just simplify it, we'll get 4 plus 6 2 6R2 plus equals to 6. Equals to 6. So from here I got my R2 as 1. So point R, which is basically foot of perpendicular, will be 2, 2, 1. Thus projection of given line on plane is x minus 2 upon 5 minus 2 3 equals to y minus 2 upon 5 equals to z minus 1 upon minus 4. So this is basically the line passing via point R and point P. So this is the required projection of the line on the given plane. So now let us move on to question number, I guess 4th or 5th question it is. So the question says that verify if the lines this and this are coplanar. If yes, find the equation of plane in which they lie. So my line L1 is x minus a plus d upon alpha minus delta equals to y minus a upon alpha equals to z minus a minus d upon alpha plus delta. And my line L2 is x minus b minus c upon beta minus gamma equals to y minus b upon beta equals to z minus b plus c upon beta plus gamma. So we have a direct formula to check coplanarity of two lines. So if two lines are coplanar, so then x1 minus x2, y1 minus y2, z1 minus z2, L1 M1 N1, L2, M2, N2 must be equals to 0, where x1, y1, z1 is a point via which line L1 is passing, and x2, y2, z2 is a point via which line L2 is passing, and L1, M1, N1 are direction cosines of line L1, and likewise L2, M2, N2 are direction cosines of line L2. So we'll just substitute values of this from the given equations and see if this satisfies. So we'll get, so my x1 is a minus d minus b minus c, y1 is a and y2 is b, and again a plus d minus b plus c, and L1, M1, N1 are alpha minus delta, alpha plus delta, and L2 is beta minus gamma, M2 is beta, and N2 is beta plus delta. So if there are two ways to move ahead. Either we can just use formula like we calculate determinant and just simplify it, but I guess that will be too complicated. So we'll just use elementary operations on this and we'll see if we can simplify it further. So if I see that my a minus b is also in this equation, and here also a minus b is there, so I'll just apply complementary column operations and see where I get. So if c1 I reduce to c1 minus c2, so I'll get my c1 as c minus d minus delta minus gamma, and my c2 is a minus b alpha beta. Likewise, I can reduce my c3 as c3 minus c1, minus c2. Yeah, so my c3 will be a minus b, so I'll get d minus c, and here it will be delta and gamma. I guess this one is gamma. Yeah, it is gamma. So if you observe carefully that now column c1 is negative of column c2, I can write it as minus of d minus c minus delta minus gamma, a minus b alpha beta, d minus c delta gamma. So there are two linearly dependent columns. So from here I can say that determinant is equals to 0. This is basically property of determinant. Or either you can just add c1 and c2, which is another elementary operation, and then one column will become 0. Then also you can conclude that this will be equals to 0. So further they have asked, so thus it is equals to 0. Thus L1 and L2 lines are coplanar. Further they have asked us to find, since it is coplanar, they have asked us to find the equation of plane in which they lie. We have earlier seen that there is a direct formula to calculate equation of plane in which they lie. So equation of plane via L1 and L2 will be x minus a plus d, x minus a plus d, y minus a, z minus a minus d, y minus a, z minus a minus d, and alpha minus delta, alpha delta plus alpha, beta minus gamma, beta plus gamma equals to 0. So we just need to simplify this to find equation of plane. So we can either just open it up or we can use the elementary row column operations like we did earlier. So what we can do is we can apply here c1 equals to c1 minus c2 and C3 equals to C3 minus C2. So from here we'll get x minus y plus t, y minus a, and z minus y minus t, and alpha will be balanced out by alpha and C2 minus delta alpha, and here we'll be left with delta. Likewise here minus gamma, beta and gamma, which must be equals to 0. Further, what we can do is we can just add this one, C1 and C3. Now using C1 as C1 plus C3. So we'll get it as x minus 2y plus z 0 0 y minus a alpha beta z minus y minus d delta gamma equals to 0. So if I just, now it is very easy to simplify. It is x minus 2y plus z into alpha gamma minus beta delta equals to 0. So this term is a constant. So my equation of plane is x minus 2y plus z equals to 0. This is my required equation of plane. So now let us move on to next question. So the next question says that find the equation of straight line via point P. Let P be 3, 1, 2 to intersect the straight line this. So if this is my point P, okay, first let us read the full question. To intersect this straight line this, so let me write this as L1, x plus 4 by 2 equals to y plus 1 by 2 equals to z minus 2 by 1, and parallel to find the equation of straight line via this point to intersect this and parallel to. So equation via point P is parallel to given plane. So let me assume my given plane be this. So if this is my given plane, so any equation passing via P which is parallel to plane will be something like this. Further it says that this straight line passing via P intersect the straight line L1. So if let my L1 line be this will be my line L1. So we are supposed to find equation passing via P which is intersecting L1, and this line is parallel to the given plane. So if equation of line via point P is intersecting L1, so there is a common point in between line via P and line L1. So any arbitrary point on L1 will be of form, let us equate it with R. So it will be 2R minus 4, 2R minus 1 and R plus 2. So for some value, let's say it is point capital R. Let intersecting point be R. So for some value of small r, this line PR must intersect line L1. So from this I can get direction cosines of PR. So direction cosines of PR are 2R minus 4 minus 3, 2R minus 1 and R plus 2 minus 2. That is same as 2R minus 7, 2R minus 2 and R. Also in the question it is given that line passing via point P is parallel to the plane. So normal to plane will be perpendicular to this line passing via P. So direction cosines of normal to plane are 4, 1, 5. So using L1, L2 plus M1, M2 plus N1, N2 equals to 0, which is perpendicular, which is condition for if two lines are perpendicular to each other. So using this we'll get 4 into 2R minus 7 plus 2r minus 2 plus 5 into r equals to 0. So from here I got 8r minus 28 plus 2r minus 2 plus 5r equals to 0. So if I simplify it, I'll get 15r equals to 30. So from here I got my r as 2. So if I got my r, then I can calculate the coordinates of point capital R. So my capital R point is 0, 3, 4. So I have 2 points of a line, that is P and capital R. Then I can easily find out value of this equation passing via P. So equation of line passing via P will be x minus 3 upon 3 minus 0 equals to y minus 1 upon 1 minus 3 equals to z minus 2 upon 2 minus 4, which is equivalent to x minus 3 upon 3 equals to y minus 1 upon minus 2, which is equals to z minus 2 upon minus 2. So I can just multiply by negative sign, or I can just leave it here. So this is the equation of line which is passing via this given plane, which is passing via this given point and parallel to this plane, also intersecting this line. So that's all they have asked in this question. So next question is, they have asked to find the distance of this point from the line this measured parallel to this plane. So let us see it graphically first and then we'll solve. So if this is my given plane, I am supposed to find the distance of this point. Let me name it as P. P is minus 2, 3, minus 4. Distance of this point P, let point P be here. So find the distance of this point P from the line this measured parallel to. So any line passing via P which is parallel to given plane will be something like this. So we are supposed to calculate the distance, and if this is my line, let's say L1. So L1 is x plus 2 by 3 equals to 2y plus 3 by 4 equals to 3z plus 4 by 5. So if this line, this is my point P, and we are supposed to find distance of this point P from this line L1 parallel to this plane. So if we can somehow calculate the foot of this point P on this line, then we can use distance formula to calculate distance of this point P from the line. Let's say this foot be Q. So we have line L1 in symmetrical form, so we can easily calculate any arbitrary point lying on line L1. So if we equate it with R, so any arbitrary point on line L1 will be 3r minus 2, 4r minus 3 and 5r minus 4. Okay, so if this is any arbitrary point on line L1, then point Q will be of this form. So we got an arbitrary representation of point Q, and in question they have given us point P, so we can calculate direction cosines of PQ. So direction cosines of PQ will be 3r minus 2 plus 2, 4r minus 3 minus 3, I guess. Yes, I think we have done some mistake. Yeah, any arbitrary point on line L1 will be of form 3r minus 2 4r minus 3 divided by 2 and 5r minus 4 divided by 3. So this will be any arbitrary point on the given line L1. So my direction cosines of PQ will be 4r minus 3 by 2 minus 3 and 5r minus 4 by 3 plus 4. So if I simplify it, I'll get 3r comma 2r minus 9 by 2 5r by 3 minus 4 12 minus 4 8 by 3. It will be plus 8 by 3. 4 minus 4 by 3. Yeah, positive of 8 by 3. So this is my direction cosine of line PQ. Also in question they have given us that we are measuring distance parallel to the given plane. So line PQ must be parallel to given plane. So if PQ is parallel to given plane, then PQ must be perpendicular to normal of plane, normal of given plane. And using perpendicularity result of two lines, we can find value of r. So using that, so my given plane is 4x plus 12y minus 3z plus 1 equals to 0. So using perpendicularity condition, we'll get 4 into 3r plus 12 into 2r minus 9 by 2 minus 3 into 5r by 3 plus 8 equals to 0. So if I simplify this, I'll get 12r plus 24r minus 54 to 12 6 9s are 54 minus 5r minus 8 equals to 0. So if I simplify it, I'll get 12 plus 24 36 minus 5 31r and 54 plus 8 minus 62, which is equals to 0. So from here I got my r as 2. So if my r is 2, I can easily find out the value of q. So point q, which is foot of perpendicular of any line passing via P on line L1. So my point Q is 6, 2 2s are 4 minus 9 by 2, 8 minus 1 by 2. Is it 1 by 2? Let me just recheck it. It will be, Q will be this point. So it will be 3 2s are 6 minus 2, 4. 4 into 2 minus 3 by 2 and 5 into 2 minus 4 by 3. That is, my point Q will be 4, 4 to say 8 minus 3, 5 by 2 and 10 minus 4, it will be 2. So this is my point Q, PQ, and we are supposed to calculate the distance between PQ. So distance PQ is, we can easily calculate it using distance formula, which is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. My point P is minus 2, 3, minus 4. P is minus 2, 3, minus 4. So PQ is equals to 4 minus 2 square plus 5 by 2 minus 3 square plus 2 minus 4 square. So if I just simplify it, I'll get 4 plus 2 6, 36 plus 1 by 4 plus 36, which is equals to 36 plus 36, 72 plus 1 by 4, which is equivalent to 172 into 4, 4 2 are 8, 7 4s are 288 plus 1 by 4, which is equivalent to 289 by 2 units. So this is distance between point PQ. Also they have asked us to find, I guess by mistake I cut the question. They have asked us to find equation of line PQ. So equation of line PQ will be x minus 4 upon 4 plus 2 equals to y minus 5 by 2 upon 5 by 2 minus 3 equals to z minus 2 upon 2 plus 4. That is x minus 4 upon 6 equals to 2y minus 5 upon minus 1 is equals to z minus 2 by 6. So this is required equation of line PQ. So let us move on to next question. I guess we don't have any more questions. Only these many questions are asked related to straight lines. So we are done with today. Thank you for watching the video.